Today we're looking at 11.4, three-dimensional figures. Our essential question: what is the relationship between the numbers of vertices, edges, and faces of a polyhedron? So starting off, we define a polyhedron as a solid that is bounded by polygons that encloses a region of space. So it's going to be a closed figure, three-dimensional. Everything, all the sides are going to be polygons. Our faces of a polyhedron are polygons, which we just said. The vertices are the points where three or more edges meet. The edges are line segments formed by the intersection of two faces. Then we have the base. The base of a polygon, right, is used to name the polyhedron. It's not always going to be the bottom, and we'll look at that as we move along. Classifying solids, polyhedrons are classified as either prisms or pyramids, right, according to their base and their sides. Prisms will mainly be made up of parallelograms. Pyramids will mainly be made up of triangles. Cross section is the intersection of a plane and a solid. So you're slicing your thing and looking at that slice. That is a cross section. So down here we have types of solids. We have a polyhedra, which is the plural of polyhedron. Those are made up of prisms and pyramids. And we have non-polyhedra, which are our cylinders, our cones, and our spheres. So all three of these are solids, but their faces are not polygons, so they're not polyhedron. And again, you can't see everything I'm pointing at. All right, we have our prism, our pyramid, cylinder, cone, and sphere. Example 1 asks us to name the solid, or tell whether it's a polyhedron first, then name the polyhedron and find the number of faces, vertices, and edges. So if it's mainly made up of triangles, it's a pyramid. If it's mainly made up of parallelograms, it's a prism. Pyramids always come to a point. It's going to be probably something you're familiar with. Here, I have three sides that are triangles, and I have a base that's a triangle. So that's a triangular pyramid. Right? I can count, I have 4 faces. I can count my edges. 1, 2, 3, 4, 5, 6. I have 6 edges. I can count my vertices. 1, 2, 3, 4. Generally, I suggest having an order in which you count, because especially on bigger shapes, it becomes harder to remember where you are. So like pyramid, I'm going to go around the base and then count to the top in both my edges and my vertices. In a prism, I go around one base, then I go around another base, and then if I have to, I connect them when I'm looking at the edges. Next shape, we have a prism. The base has 6 sides, so it's a hexagon, so it's a hexagonal prism. All right, faces, I have the top and the bottom, and then I have the 6 that connect, so I have 8. Edges, I have 6 on the bottom, I have 6 on the top, and I have 6 that connect that give me 18. And then vertices, I have 6 on the bottom, 6 on the top, so I have 12 vertices. Okay. A lot of times it's easier to count these, but we do have a formula. It's called Euler's formula. Your faces plus your vertices equals your edges plus 2. So say I have trouble, if I know my faces and my vertices, I'm looking for my edges, I can use this. But on something like this, if I have trouble seeing the edges, like these back here, some people have trouble seeing those. I can find my faces as 8, my vertices are 12, I can plug that in and solve for the edges. So if you have trouble counting, that is something else you can use. Right? Then C is not a polyhedron because you have that half a cylinder on top that is curved, so it is not a polyhedron. So we just say no, we don't have to do anything else with that. Then looking at our cross sections, it asks us to identify the shape. So here I have a plane intersecting my three-dimensional object, and I'm naming the shape that it makes. So on A, we make this shape here. That's going to be a circle. If you made the plane go through it at an angle, it could be an ellipse or an oval or something like that. Here we're going to say it's a circle. It's going straight through. The radius should be the same for all of that. B, come through. I have this shape here. That is a pentagon. Then we're going to look at some stuff with rotations. So solids of rotation. Three-dimensional figure formed by rotating a two-dimensional shape around an axis. Okay. The axis of rotation is the line around the shape. Basically, we're going to have three types of things for what we're seeing here, and they're all going to be non-polyhedron. If I have a rectangle and I rotate that, I get a cylinder. Example 4 asks us what shape we would get if we rotated these things around the axis, and here we'll see our other two. Here I have this half a circle here. If I rotate that around this line, I'm going to get a sphere. On the next one, we have a triangle here. We rotate that around, we're going to get a cone. Those are the three things we're going to get as a solid of rotation. Those are the three basic shapes you can get, because they're going to have some sort of circular there. You're not going to get a prism or pyramid. You're going to get a cylinder, cone, or sphere. You had a weird shape, you could get something that's not one of those, but it also wouldn't be one of the shapes that we've talked about here. Then example 5 again asks for our cross sections, and example 6 again we're looking at naming our shapes. I want to move this, and then you'll see the answers that are there, and I'll talk through them. All right, so example 5, cutting this pyramid, we have a rectangle. Cutting our prism here, we have a pentagon, and cutting the prism here, we have a triangle. Realize if you cut straight through, or what we like horizontal or vertical through a prism, a pyramid, or a prism, you're probably getting something similar to the opposite side. Like here, the base is a pentagon, so we get a pentagon. Here, the base is a rectangle, we get a rectangle. If you go through on more of an angle, that's when you get a different shape, like the triangle in example 5. Example 6 again asks us to name, whether it's a polyhedron, name it, and then faces, edges, and vertices. So our first one, we have a pentagonal prism, because we have the pentagon here that's the base. Realize both of these pentagonal prisms here, the base is not the bottom. The base is the side that is not a rectangle. So a lot of times you will see these where they're facing the front. This is still the base, this pentagon here. So I have 7 faces, the front pentagon and the back one, and I have 5 parallelograms connecting those. Then edges, I have 5 on the front, 5 on the back, and 5 that connect, so I have 15. And vertices, I have 5 in the front, 5 in the back, so I have 10 vertices. Next shape is not a polyhedron. Technically, following the directions, I don't need to name it, but we should know that that is a cylinder. And then our third one, I have a pyramid. My base is a rectangle, so I have a rectangular pyramid. I have the bottom, that's the rectangle, so I have 4 triangles coming up, and I have 5 faces. I have 4 edges on the bottom. I have 4 coming up, so I have 8 edges, and I have 4 vertices on the bottom, 1 on the top, so I have 5 vertices.